after that, we can set up the eye. I'm going to make room in between here. And I'm going to duplicate this one. I have to duplicate it, first of all, to keep it clean, so I don't have to draw such a long lines as I have to do here. Unfortunately, these are unavoidable, but this one I can avoid. And secondly, I'm going to distort the UV, so I'm going to offset it, because this is the eye like we've done before. And in that case, it has to be unique as well. So it's the same thing we've done with the cropped emissive. We need to bring in our own custom function. I'm gonna take the function from my finished package. There's two of them. One of the two we will make later on in the video. The fixed cropping one, however, you can just use mine. It's something that should have been working in the editor in the first place already. I just fixed it. You connect the UV one of that into UVs, and you connect the area one, the area output, into a multiply, which you multiply together with a texture, like so. Then as for the coordinates, so you add two constant, two vectors. Like that. And in fact, you can even do the following to make it even easier. Add a constant 3 vector converted to a parameter. Because if we add two of these, we can't change it in the instance, and that's not that good. So instead, I'm going to go for a parameter with two component masks. Like that. And a second one underneath. So what we do here is, or rather an append factor would have worked as well. In fact, an append factor is a bit easier. So let's just use an append factor. The first one combines red and green. The second one combines blue and alpha. Therefore, the 4 numbers found in here correspond to 2 of these. This is also 4 numbers in total. And then this will allow me to make this turn this into a parameter as it is, and call it emissive eye position, or emissive cropped position is a better name even. Group emissive. Connected like that. And then the values that we had, that we saved, were the following. So upper left corner is, and let's see what upper left corner is. Upper left corner is the bottom one, so that means blue is 0.667, alpha is 0.093. These values will be different for you if you're repeating my steps. You're not going to get exactly the same values as I have. So don't copy my values. Like so. And then this should properly translate as it does, because I can see the eye right here. Okay, that works well. Then again, the same trick as I've done before. I take a parameter, a constant 3 vector parameter, and 2 multiplies, and this will be the intensity and the color of the eye. Renaming this to eye color intensity, and group is emissive. Color of the eye should be quite yellow and quite bright. Let's see if that works. I'm going to connect it to emissive. And that shows up. One problem though, the eye shows up, but I accidentally inputted RGB into multiply. So we need the same thing here. We need a mask parameter, basically a component mask parameter version of that. And I'm going to move that one in as well. Same reason here. This will allow us to pick the right channel in each instance. So I believe it's red that it requires. And then we have an eye. You can see here on the dark side, the eye lights up. If I change the brightness here, I get a brighter eye. Or I can shut down the eye. Then we should get basic motion in. So the eye every now and then closes. In order to add that, we can use something called sine and time. I remember this from the first video. The sine and time together. Time doesn't really do anything. Time is just a point in time. In itself, this doesn't do anything at all. So if you preview this, you just get full white. But in combination with sine, it creates an animation that goes up and down. So we're going to use this animation that goes up and down to force the eye to close every now and then. Because the moment the wave is at its deepest point, the eye should close. In order to not have the eye close all the time, that would be weird, or in order to not have the eye close half the time, it should only close every second for 1/10 of a second, and then the majority of time it should be open. I will offset the height of the wave. So I'm going to add a number to it, and I'm going to be adding a very specific minus 0.99 to it. And through experimentation, I found that that's the ideal number to have it rarely go black, or in this case white. It doesn't really matter which direction it goes. Then there is something called seal. And seal, floor, and floor. You also have floor. This is the ceiling, this is the floor. This basically rounds the value that goes in. It rounds it when it goes out. So ceiling rounds it up towards the ceiling. This rounds it down towards the floor, towards the bottom. I'm going to use ceiling because this will give me the following. See, the majority of time it's black, but every now and then it very briefly gets white. So every time it gets white, he's going to close his eyes. But the majority of time when it's black, his eyes are opened. So that's the opposite of what I said earlier, but it doesn't really matter if it goes black or white. The most important thing is that the majority of time it's the single color. I could add 1 minus, and 1 minus inverts things. So now it's majority of time white, and sometimes it goes black. Because I'm going to use this in alpha, I'm going to build in a security measurement, a constant clamp, to ensure that this value never goes under 0 and never goes above 1. Because if you use a value of under 0 and above 1 in alpha, in a lerp, you might get weird results. So by adding a constant clamp in between, this will ensure that it never goes under 0 and it never goes above 1. So this is just a security measurement. And then I will use that in a lerp. As the L key on the keyboard, or also a linear interpolate. This just blends two textures together. It just blends A with B based on a third texture, based on an alpha. Or not necessarily a texture, but it blends it together based on a third input. I can show you with two colors. The majority of the time it's red, and every now and then it goes green. Therefore, the majority of time it is the texture as it is right now, which is that. But every now and then it closes its eyes, so it goes black. And by doing this, we've now created an eye that closes every now and then briefly. It's open almost all the time, but every now and then is a very brief moment where it closes and then reopens. And this is what goes to emissive now instead. One other thing I tend to do is to add ambient light to character materials. It's possible to do this via the properties of the mesh as well, but to my experience this works out a little bit easier. So what I tend to do is I tend to multiply the diffuse with a constant tree vector, which is a parameter, and which is multiplied with the diffuse. So the result of the diffuse, the whole block that becomes diffuse, and which is then added onto emissive, the existing emissive chain. And this basically allows us to add a bit of ambient light to a character. It's usually not needed, but there are cases where you want to have control over this, so I'm adding support for it to the material instance by standard, by default. And then you can always later on see where you would or would not need it. But for a character, to my experience, it's not nice if the character sometimes goes completely black. For example, in the ball, all the characters had a very subtle, small amount of ambient light. They had something like 0.06 or so of a dark blue ambient light assigned with on top. So they always kinda appear in the darkness. Could also be a good thing for a multiplayer game, for example, to help you see the enemies better, or single play.